Entanglement-based quantum networks are becoming more and more prolific and being deployed more often around the globe. These entanglement-based quantum networks are really the modern quantum network. These aren't the quantum networks of QKD past. These are quantum networks that are able to perform multi-purpose tasks and support multiple applications. These entanglement-based quantum networks communicate using something called qubits, and that communication is created using these qubits from end to end, point to point. There's also quantum information that's transferred from endpoint to endpoint via teleportation. It's a unique aspect of entanglement-based quantum networks. Quantum networks also are able to create entangled pairs of qubits. They do these from end to end, and as we'll see, they're able to do them from hop to hop as we look at more of these technologies. And these entangled pairs and the swapping of entangled pairs of qubits is very, very important in terms of establishing connections and communications and in being able to transmit qubits from point to point. These entanglement-based quantum networks are also resistant to eavesdropping. And if there's ever a man-in-the-middle attack, the actual eavesdropping can be detected and determine that a particular link is no longer a safe link. The links that are used include things like fiber optic cables, along with free space in some cases. These entanglement-based quantum networks allow us to do things like share secrets without the transmission of keys, public keys across a network, either a classical network or a quantum network. And they literally replace the public key exchange, which is one of the reasons why they're so very important, especially when you look at the eventuality of something called Q-Day, where a quantum computer will be capable of using Shor's algorithm to crack encryption keys such as RSA and Diffie-Hellman. These entanglement-based quantum networks are also able to transmit qubits between network computers, for example. Of course, quantum computers are very, very important, and gaining more traction. These quantum computers are powerful because they're actually able to operate in the qubit domain. Being able to share information between network quantum computers really requires those qubits to remain in the state that they're in and contain the information that they contain. Sharing those from one quantum computer to another means retaining that qubit state and the integrity of the qubit. It's also possible with these quantum networks to leverage qubits to actually do processing and transmission of data. This is very unlike a classical network that uses bits, bytes, and packets.